Hello students, welcome to KlassPM. In today's class we are going to discuss about reduction of purified ore to the metals at the middle of the activity series. Now in the last class we have discussed how metals are reduced, metal ores are reduced to the metals which are at the top of the activity series. In today's class we are going to discuss the metals at the middle of the activity series, how their ores are reduced to metals. So here we are talking about zinc, iron, lead, copper and tin also we can consider. These are the metals which are in the middle of the activity. It means they are moderately reactive. Okay. All these metals generally present in the form of their sulfide ores or their carbonate ores. Generally these metals, the zinc carbonate and zinc sulfide, like that. So these metals which are at the middle of the activity series, they present either in the form of sulfide ores or carbonate ores. So before they getting reduced, first they should be converted into metal oxides. First, before reduction, ores of these metals has to be converted into metal oxides. First these ores we have to convert into metal oxide, then these metal oxides should be reduced. That is the process. Okay. So there is a two different methods. The sulfide ores are reduced, or sulfide ores can be converted into metal oxide by the process of roasting. Roasting process is for sulfide ores, and for the carbonate ores we will go for the calcination method. Calcination method will go for the carbonate ores. Okay. There are two methods to convert these ores into their metal oxides. Those are roasting method and the calcination method. What is the difference between roasting and the calcination? Roasting occurs in the presence of O2 or in the presence of air. This process occurs, both are pyrochemical process. Pyrochemical process means strong heating. We are heating those ores. So strong heating in the presence of air is roasting. Strong heating in the absence of air, in the absence of air, is calcination. Okay. So to convert sulfide ore into these metal oxides, we will go for the roasting method. To convert carbonate ores to their metal oxides, we will go for the calcination method. The difference between roasting and the calcination is that roasting is strong heating in the presence of air. Calcination is strong heating in the absence of air. Why this is in the presence of air? Why not that is in the presence of air? Because, so for example, if you take the roasting, let's we take the lead sulfide. Here we have converted the sulfide ore, that is galena sulfide ore, into its metal oxide, that is lead oxide. How this process is done? Because these sulfide ores do not have oxygen in them. The sulfide ores do not have oxygen in them. That's why we have to carry this process in the presence of oxygen. That is roasting method. So calcination method, if you see that, calcination method is in the absence of air, because this process is applied for whom? Carbonates. For example, we'll take calcium carbonate. Calcium carbonate is already having oxygen in it. So if you heat in the absence of air, what happens? It will get calcium oxide plus oxygen. Calcium oxide plus carbon dioxide we will get. So here already oxygen is present in the carbonate ores. That's why we have to carry this process in the absence of air. No need of oxygen, because already oxygen is there. But in the sulfide ore there is no oxygen. That's why we have to carry in the presence of air. This process is called roasting and this process is called calcination. Both are pyrochemical process. Pyro means we are heating them. Okay, it is heating. One is in the presence of air, one is in the absence of air. So the metals ores which are in the middle of the activity series, before they get reduced, they are converted into metal oxides. Now how these metal oxides are reduced, now we will see now. Okay, after converting the purified ores into their metal oxides, the next stage is reduction of those metal oxides. So there are different four methods are there. Reducing metal oxides to metal. The first method is that reduction of metal oxide with carbon. Okay, we can do the reduction with the carbon. So we can take an example here. Lead oxide is heated with the carbon, that is coke, and at the temperature of 1400. Generally it will do in the very closed furnace. We will carry this particular reaction in the closed furnace. So we will get the metal from their metal oxide. and carbon monoxide will be released. The second method is that reduction of metal oxide with carbon monoxide. By reacting with carbon monoxide also we can reduce the metal oxide. So here we can take the example of iron oxide. When iron oxide is reacted with carbon monoxide, we got iron along with carbon dioxide. Okay. So the third method is that auto or self reduction. Generally this method is used for the sulfide ores. So for example, if you take the copper sulfide ore, that is copper pyrites. So copper pyrite is the sulfide ore of copper. Now this is first converted into its metal oxide. So when copper sulfide ores reacted with the oxygen, we will get the copper oxide along with sulfur dioxide. Okay. Now this is done in the presence of air. That's why you can call it as a roasting. So in this roasting process we got the copper oxide, but total copper pyrite is not converted into copper oxide. Some copper sulfide is left. So to utilize that copper sulfide also, what we have to do is we have to stop the supply of oxygen and we have to increase the temperature. We have to stop the supply of oxygen, no absence of oxygen. Now, and also what we have to do, we have to increase the temperature. For that, what happens? The remaining copper sulfide, that is copper pyrites, react with copper oxide and it will form the copper along with sulfur dioxide. This is called auto reduction or self reduction, because here we are used as reducing agents. Coke we have used here carbon monoxide is used as a reducing agent, but here in the auto and self reduction we are not using any reducing agent, itself is reducing it. That's why we are calling it as auto or self reduction. So in this process what we are doing, generally this auto or self reduction is used for the sulfide ores. We are considering copper sulfide ore, that is copper pyrites. So here copper sulfide is reacted with the excess oxygen, so it forms the copper oxide along with sulfur dioxide, but the total amount of copper sulfide is not become copper oxide. Some copper sulfide left here. So to utilize that copper sulfide also we have to stop the supply of oxygen and we have to increase the temperature. With that, what happens? The remaining copper sulfide also react with copper oxide and it forms the copper. This is the third method. And the fourth method is that reduction of ore by more reactive metal. So if there is a metal compound with a low reactive metal, that low reactive metal compound is reacted with high reactive metal, what happens? The high reactive metal displaces the low reactive metal. So here titanium chloride is a compound ore that is reacting with highly reactive metal, that is magnesium. Magnesium is highly reactive when comparing to the titanium. So what happens? This magnesium replaces the titanium so that we can extract the titanium. Here another example, titanium chloride is also reacted with sodium, because sodium is also top of the activity series, which is also highly reactive. Okay, so this sodium displaces the titanium so that we will get the titanium. So that's why by here the highly reactive metal is used as reducing agent. Highly reactive metals are using reducing agents. So these metals displacing the low reactive metals from their ores, so that metal is low reactive metal can be extracted in this method. So here one important process in the reduction of ore by more reactive metal is thermite process. This is have very wide application in our day-to-day activities, especially in the industrial purpose. This is having very wide act. What is this thermite process? When iron oxide is reacted with highly reactive metal like aluminium, so it forms aluminium trioxide along with iron. In this process lot of heat is produced, so that this is highly exothermic. That's why the iron formed in this reaction is in the molten state. The iron formed in this reaction is in the molten state. This is in the molten state because in this lot of heat is produced. That's why this is highly exothermic. That's why iron produced in this reaction is in the molten state. So this molten iron is used for attaching broken rails of the railway tracks or broken machinery parts in the industries or in the railway. So those broken railings of the railway tracks can be attached by this molten iron, or also machinery parts, which are large machinery parts, huge machinery parts can be attached by this molten iron. This process is called thermite reaction or thermite process. Okay, these are the different reduction methods of converting metals of the metal oxides of into their metals which are at the middle of the activity series. So what is the first method? Reduction of metal with carbon as reducing agent. Here carbon is reducing agent. Here carbon monoxide is reducing agent. This is self reduction, generally used for the sulfide ores. And this is the here reduction reducing agent is more reactive metal. And the thermite reaction, the reaction between iron oxide and aluminum is called thermite reaction. This is in this reaction the iron produced is in the molten state, that is used for attaching broken rails of the railway tracks and also machinery parts.